So this time we will talk about matrix addition. So there are two rules that you have to remember in doing matrix addition. So the first rule is that you have to see to it that the two matrices that you are adding are of the same order. So meaning the number of columns and the number of rows are equal. Then second, you have to add each corresponding elements. Meaning, if you have a matrix A added to matrix B, it means that each element in your matrix A should be added to the same element of your matrix B. These are the things that you have to remember. So you have to take note of this. For matrix subtraction, the rules are almost similar to your matrix addition. So there are two rules. The first rule is that you have to make sure that the two matrices have the same order. The second rule is that just keep on subtracting the corresponding element of your matrices. So for example, you have a matrix A subtracted with matrix B, then it means that your A, matrix A, every element of your matrix A must be subtracted with the same position and element on your matrix B. Okay? Almost the same with your matrix addition. You have to remember to follow these two rules. Okay, so let's have another operation of matrix, which is the multiplication of matrix by scalar. So when we say scalar, it means a number. When you do multiplication of matrix by scalar, it means that you have to multiply each element by scalar or by a number. So basically, this is how you do it. C here corresponds to your scalar number, and A here is your matrix. Multiplying a scalar to your matrix means that you have to multiply that number to each element of your matrix. Let's have some examples of each operation for matrix. So let's say we have this matrix. And another matrix. So matrix A has these elements, and matrix B contains these elements. Okay, so what we are going to do is to, for our example 1, using these matrices, what we will do is we will add matrix A to B. Okay, take note of the rules that I have mentioned you a while ago that you must remember when you are doing addition of matrix, subtraction of matrix, and multiplication of matrix by scalar. So for addition of matrix, you must ensure that both matrices are equal. When we say both matrices are equal of the same order, is that the number of rows and columns is the same with the number of rows and columns for the other matrix. So we have 2 columns and 3 rows for matrix A, and then 2 columns and 3 rows for matrix B. So meaning they have the same order. 1, 2, 3, 3 rows. 1, 2, 3, 3 rows. 1, 2, 2 columns. 1, 2, 2 columns. So they have the same order. Okay, so meaning it is possible to add these matrices. So to do that, what we are going to do is to add each element. 1, so it goes like this. 1 plus 2, and then 3 plus -1, and then 3 plus 3, and then 4 plus -2, and then 5 plus 0, and then 6 plus 1. Okay, so this is how we will add matrix A to matrix B. Then let's perform and simplify this operation. So 1 plus 2, that is 3. 3 plus 3, that is 6. 5. And then this is negative, this is positive 2. And this is positive 2. And this is 6 plus 1, 7. Okay, there you go. This is now the answer. Okay. So we're able to add A and B because they have the same order. Both matrices have the same order. So adding A to B with these elements will give us this new matrix. Okay, so let's have another example. We will use the same examples that we had on our previous example. So for our A, we have 1, 3, and 5, then 3, 4, and 6. For our B, we have 2, 3, and 0, -1, -2, and 1. Okay, so this time we will try subtraction. So let's try to solve this A minus B. Again, in our explanation a while ago about the rules for subtracting two matrices, if you can still remember the rules, we have here two matrices must have the same order, and then after you check the order of the matrices, you just subtract each element. So the way to do it is just for the first element, you have to subtract it the same element on your matrix P. Okay, so let's check. Do they have the same order? Yes, they have, because we have 3 rows, 1, 2, 3, 1, 2, 3, and then 2 columns, 1, 2, 1, 2. So they have the same order. So meaning it's possible for us to subtract A and B. But if the order are not the same, then it's impossible for us to do subtraction of these matrices. So let's try to solve this problem. So to do this is we subtract 1 by the same position of other element, which is 2. So 1 minus 2, and then 3 minus 3, and then 5 minus 0. And then on the other side, 3 minus negative 1, 4 minus negative 2, then 6 minus 1. Okay, so now let's solve this. 1 minus 2, this is negative 1. 3 minus 3, this is 0. 5 minus 0, this is 5. 3 minus negative 1, this becomes 4. And then 4 minus negative 2, this becomes 6. Then 6 minus 1, this becomes 5. So this is now the answer. Okay, so that's how you solve A minus B. Okay, so let's try a different example. So this time we will do multiplication by scalar. Matrix multiplication by scalar. Okay, if you can still remember a while ago, the way to do multiplication of matrix by scalar is just you multiply that constant number to each element you have on your matrix. Okay, for us to see how it works, let's take this example. Let's say we have 4. Let's say we have 4 times A. So the way to do it is we have 4 here multiplied by A, and then 3, 4, 6. Okay, so 4 times 1, this becomes 4. 4 times 3, this becomes 12. 4 times 5, this becomes 20. 4 times 3, that is 12. 4 times 4, this is 16. 4 times 6, that is 24. Okay, so there you go. We were able to solve 4 times the matrix of A. So this is now the answer. Okay, so let's have another example. So this time let's take, let's say 2A minus, or let's turn this to a higher number. Let's say 5A minus 2B. So 5A minus 2B. So we have a scalar, and then we have subtraction. So let's start with a scalar. Okay, so 5A. So this means that we have 5 multiplied by A. So A is 1, 3, 5, 3, 4, 6. So this becomes 5 times 1, this is 5, this is 15, and this is 25. 5 times 3, this is 15. 5 times 4, that is 20. 5 times 6, that is 30. So this is now our 5A. This is now our 5A, the result of 5 times A. Okay? So for 2B, we'll write here 2 and then B. B is 2, 3 and 0, negative 1, negative 2, and then 1. So 2 times 2, that is 4. 2 times 3, that is 6. 2 times 0, that is 0. 2 times negative 1, this is negative 2. 2 times negative 2, that is negative 4. And then 2 times 1, that is 2. So this is now our 2B. Okay. So please pause this video and then copy everything here so that we'll be able to erase this and continue solving 5a minus 2b, because what we did here is just getting the scalar, okay, the result from this scalar. So we were able to get now the scalar 5 times a, so this is now the result. 2 times b, this is now the result. Now what we will do next is to subtract the result of this, the 5a, to our 2b. Okay, so pause the video and then we will continue. Okay, so this is now our 5a, and this is our 2b. So we will now perform subtraction. We will now do a subtraction of 5a and 2b. So to do this, 5 minus 4, this is 1. 15 minus 6, that is, this is 9. 25 minus 0, that is 25. Or 15 minus negative 2, that becomes positive, so it will become 17. 20 minus negative 4, this becomes 24. And then 30 minus 2 becomes 28. So this is our final answer. Okay, there you go. And that's how addition, subtraction, and multiplication by scalar in matrices. Okay, so for the last example, let's consider this given. For our a, let's say we have the square root of 8, 2, and then 0, 1, and 0. Then for b, so let's say we have here the square root of 2, negative 1, negative 3, and then 6. So considering this given, let's try solving a plus b. Okay, so a plus b, how will you do this? Okay, just the same steps that we have performed in our previous examples. So it means that this becomes square root of 8 plus the square root of 2, and then 2 plus negative 3, and then 1 plus negative 1, and then 0 plus 6. Okay, let me compress this for a while. Rewrite this so that we have enough space at the right side. Okay, so this means that we have to do some radicals here because we have radical expressions here. So now this becomes, we have to take out 2 because basically we have 8. If we have 8, this is 4 and 2, and this is 2 and 2. So we have to look for the last node. The last node here are this. And then we have to get rid of pairs. So this is 2 and 2. We have to get rid of the pairs. So the last remaining node is 2. So that is why what is left here inside, is 2. So this becomes 2, and then the other side of the 2 will be taken outside, because as you can see, because our 8 here, when we say 4, 2, then 2 and 2, so the 2 here is taken outside, so this is now the 2. It will replace outside the radical symbol, and then what is left here is this 2. So this is why we have the 2 remained inside the radical symbol. Okay, so that's the reason. Okay, so let's continue solving this. So plus 2, and then this is 2 minus 3, this is negative 1, and then 0 plus 6, that is 6, and then, I'm sorry, this is 6, this is 6, and then 1 plus negative 1, and this is 0. Okay, there you go. So what is the final answer? We have not yet arrived at the final answer. So now let's continue. So we can still simplify this radical operation, because since we have similar they have similar coefficient, it's like the coefficient in your polynomials. If you are going to recall your polynomials, it's look like they have the same coefficients. Since they have the same coefficients, we can perform addition of radicals. So this means that 2 plus something here, an invisible 1 here, this becomes 3. Okay, so I'm going to write it down just below this. So this becomes 2 plus 1, this becomes 3, and then we will just copy the number, the number inside the radical symbol is 2, and then we'll copy everything from here, 6, 0, and negative 1. So there you go, this is now the final answer. So why we got 3 here? Because we have an invisible 1 here, just like with your variables. When we say x, consider always that there is an invisible 1 here. Okay, so we have an invisible 1 here, so 2 plus the invisible 1, it becomes 3, and then we'll just copy the 2 inside of the radical symbol. Okay, so that's all. Okay, so let's have another example. So this time let's try a minus b. So to do that, let's write here square root of 8 minus the square root of 2, and then 2 minus negative 3, and then 1 minus negative 1, then 0 minus 6. And then this becomes, so again, we have already solved this one. And then this becomes 1 minus negative 1, this becomes 2. 2 minus negative 3, this becomes 5. And then 0 minus 6, this becomes negative 6. Okay, so we're not done yet, because we can still simplify this. 2 minus the invisible 1, it becomes 1. So meaning 2 minus the invisible 1 becomes 1. So we have 1, so we can just omit 1, no? Then let's just write here can write here square root of 2, because it is always considered that you have an invisible one here. So that is why there's no need for us to write that one. And then we have 2, we have 5, and then negative 6. So this is not the final answer. Okay, so there you go. Then last example, two last example. Let's say we have 4 times a. Okay, so this means that we have here 4 times the square root of 8, 1, 2, and 0. Okay, so now let's simplify this. So this becomes, we know how to perform simplification of radical. So it means that this becomes 4 times 2, square root of 2, and then 4 times 1, and then 4 times 2, and then 4 times 0. Okay, then this becomes 4 times 2, this becomes 8, and then we'll just copy square root of 2, and then 4 times 2, that is 8, and then 4 times 1, that is 4, 4 times 0, that is 0. So this is not the final answer. Okay, then last example. Let's say we have 5 a minus 3b. So again, we have to solve first for this. Part, and then next one is we solve for this part. Okay, let's start with 5a. 5 times, what is our a? Square root of 8, 2, 1, and 0. So to do this, 5 times 8, 5 times 2. So we have here 5, 2, square root of 2, and then 5 times 2, 5 times 1, 5 times 0. And then this becomes 5 times 2. This becomes what? This becomes 10. So 10. And then we'll just copy the radical symbol together with 2. And then 5 times 2, still 10. And then 5 times 1, 5. And then this is 0. Okay. There you go. So this is now our 5a. Okay. This is now our 5a. Let's write here 5a. So for 5b, for 3b, we'll do here 3 times, what is the value of our b, or the elements of our b? Square root of 2, negative 3, negative 3, square root of 2, negative 1, 6. And then we will multiply each. So to do this, we have 3 times 1, 3 times 1, because we have an invisible 1 here. 3 times 1, that will become 3, and then we'll just copy the radical symbol and the 2 inside of the radical symbol. And then 3 times negative 3, that is negative 9. This is negative 3. 3 times negative 1. And then 3 times 6, that is 18. Okay, there you go. So this is now our 3b. Okay, so let's fix everything. Let's erase this. What we left here is just the 5a and 3b. Okay, I'm going to erase this for a while. For our 5a, the matrix for our 5a is 10, square root of 2, 10, 5, and then 0. And then for our 3b, remember that we have a subtraction operation here. So minus our 3b, 3b is 3, 2, negative 9, negative 3, and then 18. Okay, so let's perform the subtraction between these matrices. So we can perform subtraction between these radical numbers because they have same coefficient, as if like with polynomials, same coefficients, same radical numbers, 2 and 2. So this is why 10 minus 3, this becomes 7. Then we'll just copy the 2. Okay, and then 10 minus negative 9, this becomes 19. And then 5 minus negative 3, this becomes 8. And then 0 minus 18, this becomes negative 18. So there you go. So this is now our final answer. Okay, so that's all for this video, and then see you in the next lectures.